Okay, for this we're going to be solving yet again systems of equations by substitution, except for some interesting things will happen. Well, interesting to me, maybe not to you. Is this light on? It is. So let's see. We're solving it by substitution. Let's take a look at the first example. So we have an equation. Let me take this out. Or a system of equations, rather. And what we are going to do, or what the steps said to do before, was to pick an equation that has a variable that's easy to solve for. This one already has x by itself, so I'm going to use that. And I'm going to plug this into this equation. So the first step is already done, where we have to solve for a variable. But now, since x equals 7 minus 7y, I'm going to take that and use my other equation. I'm going to take this, whatever x is, or actually x is 7 minus 7y. So instead of writing an x here, I'll write 7 minus 7y. So 2 parentheses plus 14y equals 4. And then I'll plug in that, because that's what x is. So 7 minus 7y. And distribute. Let's see what happens here. So this would be 14 minus 14y plus 14y equals 4. So that cancels out with that. These are like terms. I can combine them. And then I get 14 equals 4. And this is obviously false. Facile. False. So this is one of the special cases. If you take one equation and do all the steps correctly, but you get a false statement, 14 equals 4, that's not true. That means these two lines are actually parallel lines. And if you remember, the type of solution for parallel lines is no solution, because they never intersect. So the answer here is no solution. Very simple. So whenever you do all the steps correctly from before, but you get something that's false, like some number equals a different number. If you get 0 equals 0, or 4 equals 4, or 14 equals 14, that's different. But we got a false statement here, so the answer is no solution. It corresponds to no solution. Two parallel lines. If you wanted to, you could get both of these in y equals mx plus b form, and you'd see that they have the same slope. But we're going to look at this next example, just to keep it simple and keep the video going. Again, solve by substitution. This is already solved for. The x is already solved for. And so I will plug it into this first equation, plus 6y, and you can see what happens here. So if I plug in the negative 2y, I get negative 6y plus 6y equals 0. Those cancel out to 0. So I get 0 equals 0. That is a true statement, which means that these two lines, if I simplified and got it into y equals mx plus b form, you'd see that they're the same line. So remember, when you're solving a system of equations, the solution is wherever the lines touch, wherever they share a point. And in this case, they're the same line. So they're just drawn right on top of each other. So any point on the line is a solution. And there's infinitely many points on the line, so you can say infinitely many solutions. And that would be the answer for this. So those are the special cases. One of them where you get a false statement, then you say no solution, because the lines would be parallel. Or you get a true statement. That means the lines lie right on top of each other, or they're the same line. So that's infinitely many solutions. And that's it. You're done. Goodbye. Go home. You're already home.